Yeah, today we are going to start with a new topic, that is the hydrogen. And before we do that, I just want you to I just want that you should be familiar what actually we are going to study, that what actually the hydrogen is, right? So just going on or you can say just putting the light on the history of the hydrogen. So I'm just telling you, so just keep in mind they are the important points, right? So earlier initially you can say it was called as inflammable gas. There was no name like hydrogen, it was just regarded as an inflammable gas, right? We are talking everything about the hydrogen, right? So initially it was just called as inflammable gas, right? Then what happened in 1672, the Robert Boyle was the one who just studied and proved the elemental state of the hydrogen. But till that time also we were not calling the hydrogen as hydrogen, we were just calling it as an inflammable gas. But still it was proved that yes, it is made up of an element, right? And then in 1776, soon after you can say the 1672, then in 1776, Henry Cavendish was the volunteer who just you can say was the one who synthesized the hydrogen gas in the lab, and he just proved that yes, it is an inflammable gas. That means when it is burned in air, it results into formation of water, right? So after only the few years after, like in 1776, Henry Cavendish proved this, and soon after in 1783, the Lavoisier just named this inflammable gas as hydrogen. So the name given to the hydrogen was by Lavoisier. It's not like that randomly that he suggested the name and he just kept the name as hydrogen. No, it means something. So just look at the board, I'm writing the meaning for it. So hydro means out of hydrogen, hydro means water, and ogen means producer. And as it was already proved by Henry Cavendish that when it is burnt in air, it just burnt in air producing the water. So that means it is a water producer. That is why it is the name which was given to this inflammable gas was water producer, that is the hydrogen, right? So I think you are familiar with it. Now the second question which must be striking in your mind, that where do we get this kind of gas, right? So it is just present almost everywhere, but you can say the percentage in which it is present is very small, but in few you can say substances we get to see the more percentage of hydrogen. So just I am putting the light on that so that you should be clear in your mind that where do we get this hydrogen, right? So hydrogen occur in nature in free form also and in combined form also, right? So you must be familiar, but still I am recalling it for you. So in free form, where do we get? We get in earth crust, right? But the percentage, again I am repeating, is very small, it's not too high. We get in atmosphere also, but still the percentage is very small, it's not you can say the big one. And the moreover we get it in you can say in many, almost every substance has the hydrogen, not every, but still has, but the small content is there, right? But the content of hydrogen you can say is contributing a great in case of stars and sun. You know, the stars and sun mainly composed of hydrogen. The nuclear fission reaction, you know, that is responsible for the energy which we are getting from the star and the sun is just because of the hydrogen which is present in them, and the hydrogens are just combining to form the helium. And it is just you can say they assume, like the question must be arising, that when all the hydrogen in the stars or the sun will get converted into helium, what is going to happen? Will be able to see the sun or not? Right. So we'll be able to see the sun, because at that time the new kind of nuclear reaction is going to start, in which the helium will start combining and just forming the carbon. And then if we say that yes, the carbon all content helium is being lost, then what happens? Then a new kind of nuclear fission reaction is going to start. That means sun is going to last for many billions and trillions years, right? So that is beyond our scope. That means that is not included in this chapter. We'll be just considering the hydrogen. I just told you about the star and sun because I just want you to you can say remember it, that the stars and suns are mostly composed of the hydrogen, and it is the hydrogen only that is responsible for the light which we are getting from the sun. So hydrogen is, again, that means is a important element, right? So it is, as I told you, it occurs in a free state. So the question comes, where it occurs in a combined form. So have you ever seen the hydrogen occurring in a combined form? Any idea if you have? so I think you can easily recall it. Yes, the water, right? The water is H2O. So that means it has hydrogen combined with oxygen. So that means the water which we get in is a combined form of the hydrogen, right? And moreover, we get the hydrogen in the plants and animals also, right? And moreover, it is you can say it is just a component or a constituent of many organic compounds as well, like carbohydrate, proteins. What is carbohydrate basically? It is C6H12O6. So that means it carries in hydrogen. So that means in it the hydrogen occur in a combined form. Similarly, in case of proteins, like we have proteins, the amino acids, they are all the nitrogenous compounds, and along with that they have the hydrogen as well. So that means again the hydrogen is present. Similarly, it happens with the fats also. So that means hydrogen occur in the combined state in organic matter as well. Right, and though we get the hydrocarbons, that is the compounds of carbon and hydrogen, they are forming almost everywhere they are present. So that is why we have a different chemistry to study about the carbon and its compounds, that is the hydrocarbon, the organic chemistry branch. Right, so that means the hydrogen is a main just acting as a main constituent, and it is present in the combined as well as in the free state. Right, so I think it's clear that what actually I'm just repeating the points for you so that you can easily recall it. So I just told you that what was the initial name of the hydrogen? You know that it is an inflammable gas, right? And who was the first who just studied the elementary state of hydrogen? Yes, you are right. It is the Robert Boyle. And who was the one, like you can say, who just synthesized this gas in lab and just proved that yes, it is an inflammable gas because it burns in air to form water? You're right, it is Henry Cavendish, right? And the third, who gave the term hydrogen? Who gave this name? Yes, it is Lavoisier, right? So you need to remember these names, and even if you can recall the years also, that is the important part. See, whenever you study something, just make yourself as an exceptional case. Everybody is going to just everybody is going to just study the hydrogen properties and all. They'll be studying everything, but what they will be, you can say, what they will just keep in mind will be only the properties and all. So don't miss the scientists, don't miss the dates. Just you can say, when you're studying something, I told you before also, just get into it, right? And because you have to make yourself exceptional case, and if you'll make yourself an exceptional case, that means with exceptional knowledge, then only you are going to succeed, because it is a era of competition, right? So just I told you this thing, just that means just remember the dates as well as the scientists wherever they are used, or the experiments and where they are needed, right? So coming to the topic which we were discussing. So you know that now how hydrogen is occurring in the nature, that is in the free form or in the combined form, what kind of forms are there, you know that now. So now before we start, I just want you to know that as we know that hydrogen is an element, so that means it must be possessing some symbol as well. So what is the symbol for the hydrogen? You must be familiar with it, but still I'm writing it for you so that you can easily remember it. So it is hydrogen, right? H. That means the first letter, right? And it was told by, as you know, that Berzelius suggested that the symbols can be picked by the first letter, can be picked by the first two letters, and also can be obtained from the first two letters or first letter of the Latin name. So in this case, the hydrogen, that means the first H has been used as a symbol, right? And now talking about the atomic number. So what is the atomic number, which shows that how many number of protons it has? So it has only one number of protons, so that means its atomic number is 1. So that means it comprises of 1 proton, right? And as we know, the number of protons is always equal to the number of electron, that is the negative charge in an atom. That means electron is also 1, right? So similarly, the mass number, if we talk about the mass number is also 1. Right. So when we'll be discussing that, now you know that what is the symbol, what is the atomic number, what is the mass number, and you can easily write the electronic configuration as well. So what is the electronic configuration? Though it has only one electron, so that it will be filled in only the first shell. So that means electronic configuration is also only 1. right? So as we know that everything in the universe need to have stability. I told you in the previous lectures as well that everything in the universe is just moving for the sake of stability. Everything needs to be stable, and for that what they are doing, they're just struggling for stability, right? So when we talk about in case of elements, what kind of struggle they are doing to attain stability. So they just need to complete their valence shell, and when the valence shell is complete, that means they have attained the state of lowest energy and maximum stability, right? So in this case it has one electron in its valence shell. So how it can attain stability? What do you think? It will lose an electron or it will gain an electron? Yes, you are right. It can do both of the case. That means either it can accept one electron forming the H negative, and even it can lose this one electron forming the H positive ion. So it can do either of. Now it has been a great difficulty because this element can even gain electrons like non-metals do, and it can also lose electrons like metals do. Now the question comes, where it will be placed in the periodic table? The question must be striking in your mind that if it behave as a non-metal, that means it is showing an electronegative character as well, and it is showing an electropositive character as well. So where do we place hydrogen, right? And when we were discussing the periodic properties, I told you that the hydrogen is the first element of the periodic table, right? So when you look on the periodic table, you will get to see that hydrogen is placed here, and below lithium, sodium, potassium, that is the alkali group is present, right? So it acts as the first element of the periodic table, like this, right? But you know that here is a noble gas, 18th group. This is the first group, and here we have 17th group as well. So in 17th group is a halogen group in which we write fluorine, chlorine, bromine and iodine. Right. So that means the hydrogen is exceptionally placed in the first period because it doesn't resemble the helium, right? And it resembles somehow with the alkali metal group also, and also with the 17th group. Now I just want you to know that what kind of similarities it shows with the the typical metallic group and with the typical non-metallic group. And as you know now that it can either gain electron and it can either lose an electron. So that means losing an electron indicates the you can say a property of metals, that means the most metallic ones, right? So it can be put in this group also. And similarly, how I have shown you that it has a tendency to gain electron also. So that means it possesses the non-metallic character. And out of this periodic table, the maximum electronegative elements, or you can say the maximum non-metallic character, is of 17th group due to its exceptionally small size, right? So that means it resembles the 17th group as well. So that means the hydrogen can be placed in both the groups as it resembles both the groups. But we cannot place the same element in two different groups. That is why it is placed in the group 1 and period 1. That means the first element of the periodic table, right? Now the question comes, what kind of similarities it possesses if we compare it with the metallic group, that is with the alkali metals and with the non-metals. So I am just going to list the similarities so that you should know that's why I was talking that it resembles the alkali metal and it resembles the non-metallic group as well. So now I am comparing it with the alkali metal first. Now what kind of similarities it shows with alkali metals? So alkali metals are actually this first group, living hydrogen. We have lithium, sodium, potassium, rubidium, cesium and francium. We are not taking francium because francium is radioactive, so somehow it shows properties different from its group members, right? So I am taking the alkali metal group starting with lithium, right? So we have this group of alkali metals. So we are just focusing that what kind of similarities it possesses with the alkali metals. So first, the first similarity I am going to show you is the electronic configuration, right? So I am writing the electronic configuration for the alkali metal group. It is 2,1, it is 2,8,1, it is 2881. Similarly this, right? So, and I am writing the electronic configuration for the hydrogen as well. As you know, the atomic number is 1, that means the proton is 1, obviously the electron is 1, and electronic configuration is also 1. So what kind of similarity do you get to see within alkali metals when I compare it with the alkali metals? Yes, you are right that the valence shell has got one valence electron, and even it has the one valence electron. That means it shows the similarity in the electronic configuration, that because the valence shell electron, not the valence shell, because valence shell is the last shell. In this case, the valence shell is L, then M, then N, and it only has K. So I am not talking about the valence shell, I am talking about the valence shell electron, that is the valence electron. So when I compare hydrogen with the alkali metal group, it has been clear that the alkali metals has one valence electron, and similarly the hydrogen has one valence electron. So that means they resemble alkali metal in case of when we talk about electronic configuration. Right. Now the second property what I am considering is the electropositive character. Now what is this electropositive character? We know that the metals have tendency to lose an electron, and after losing they acquire positive charge. Like we know that it is a property of the typical metals, that means they are electropositive. They donate electron, and after losing the electron they get the same number of the positive charge on it, right? So similarly, like I am just stating an example for you. So it is for the lithium I am writing. Suppose lithium is Li, you know, atomic number is 3, electronic configuration is 2, 1. It loses one electron, and after losing it forms Li positive, right? And similarly, I have told you before also that we can do it for the hydrogen also. Hydrogen also has one electron, one atomic number, one electronic configuration. It can also lose its one electron, and after losing, it is also going to form an electropositive ion. So again, the similarity lies here. See, it also forms unipositive electropositive ion, and similarly, it is also a univalent. That means it, after losing one electron, its one valence electron, it has just acquired the one positive charge. So that means the electropositive character which we were talking is similar, right? So the third property which we are going to discuss is the kind of compounds it forms, or you can say it has that what kind of affinity it has for non-metals. So like the lithium, sodium, potassium, they readily combine with the non-metals as I am showing you. See, Na has 1 electron, chlorine has 7 electrons, we know that, right? So this sodium just give its 1 electron to it, and after losing it acquires the noble gas configuration, and after gaining it also acquires the noble gas configuration. And what they do, they just combine to form the lattice, that is the Na positive, Cl negative, crisscross NaCl. You know that, right? How it is done, right? We have discussed in language of chemistry as well. So this is NaCl. So that means the all metallic group, all metals are just electropositive. That means they have tendency to combine with the electronegative elements, that is with the non-metals. So similarly, the hydrogen has that tendency to combine with the non-metals. That is why we get to see many compounds of the hydrogen in which it is linked with the non-metals, like H2O, H2S. So that means in which the hydrogen is just linked with the non-metals, right? So that means it is the third property in which it resembles the alkali metals. The more property is that it acts as reducing agent. Like the alkali metals act as reducing agent, they also act as reducing agent. Now the question comes, what is the reducing agent, right? We discussed in the chemical reactions as well. I told you reducing agent is a substance which make the other substance reduce, but in turn gets itself oxidized. Now the question comes, what is oxidized or reduced? So we have different concepts for explaining that, and I think you can easily recall that if we talk about the oxygen and hydrogen, any element which loses the hydrogen is getting oxidized I'm just considering the hydrogen in this case. Otherwise, we can explain this definition by taking an example of oxygen as well, right? But because we are considering hydrogen, so that is why I'm just explaining on the basis of the hydrogen, right? So oxidation is carried out when an element just loses an hydrogen, right? And when any other substance just gains the hydrogen, is said to be a reduction is occurring at that place, right? So that means, and moreover, if we talk about the electronic concept, this is just the you can say a classical concept definition that is on the basis of oxygen and hydrogen. But if we talk about the electronic concept, then the one which is losing an electron is just acting as a reducing agent. That means it is undergoing oxidation, but it is making other substance reduce. So similarly, that means any element which has the power to lose an electron can act as a reducing agent. And as I've shown you that like alkali metals, hydrogen can also lose an ion to form electropositive ion. So that means they just get themselves oxidized and making the other substance reduce. That means they are losing an electron and they are just making the other element gain that electron, right? So that means in a similar way it resembles the alkali metal. That means like them, it also acts as reducing agent. So these are the 4 similarities which in hydrogen show as compared to the alkali metals, right? And what are those similarities? I'm repeating again for you. One is the electronic configuration, as we have just I've shown you that one valence electron, it also has one valence electron. That means the electronic configuration is similar even though the valency is similar, right? The second is electropositive character. That means it has a tendency to lose electron, and after losing it is acquiring a positive charge. And what number of positive charge? 1 positive charge, as it is done by the alkali metals. Third is the kind of compounds, that means whether they have affinity for non-metals or not. So yes, it has the affinity for combining with the non-metals, like the alkali metals have that tendency, right? The fourth is the reducing agent. We know that any substance which supplies hydrogen, you can say which supply electron to the other substance, or which supply hydrogen to any other substance, it acts as a reducing agent. So similarly, it is acting as a reducing agent. On the basis of alkali metals, we are talking on the basis of electronic concept. So similarly, we can talk for the hydrogen on the basis of electronic concept, though we know that both are electropositive. They have one valence electron, they can lose that one valence electron, and they can just form electropositive ions. So this is the similarity what in hydrogen possesses when it is compared with the alkali metals, right? Now we have the justification now that why hydrogen is placed, or you can say what are the similarities that the hydrogen is linked with the alkali metals. You know the similarities now, right? Now we'll be discussing that what similarities it resembles with the 17 group, right? So I'm just rubbing it. I hope you have got it, the similarities of hydrogen with alkali metals. It's not too tough, it's too simple, because if you are just familiar with the basic concepts which we have done so far in the chemistry, then it is not a big deal for you to list out the similarities, right? And once you will go through it, you will be able to hold them for a longer period. So don't worry, just learn it, get into it, and it won't be a difficult task for you to remember, right? So we'll be discussing the properties of the hydrogen with the have 17 group. So 17 group is the halogen group, and the elements we have is fluorine, chlorine, bromine and iodine, right? So we'll be discussing that what kind of similarities it possesses with the halogen. So the first similarity is that to attain its stability, it also needs one electron, right? So how I am showing it, so just look at the board carefully.